Before looking at our Sizer plugin, let me show you how you can get Sizer. So there are a couple locations where you can download, purchase a license. So it's a subscription. There is a Canadian and a US version. So you see, you could go to the Woodworks software website or to the Canadian Wood Council, where there is also a Woodworks a software portion. Then in Cadwork 3D, once you've installed Sizer, you can go to Window, Cadwork plugins, and here you will see that uh, the Sizer plugin is available. So this is our latest version of the Sizer. We've been supporting Sizer for probably around 10 years, even more. But the new version yeah, is a lot more powerful. It's been improved quite a bit. So the first step is to highlight or activate a part you want to check. So let's check this eye joist. So I've taken the eye joist. So if you're willing to test or check in Sizer, uh, any of the eye joists we've got here, it's not working for all the eye joists. So not all the vendors are built into Sizer, so we rely on uh, like parts that are built into the Sizer library. So by adding a standard beam, here you see that we've got eye joists from different suppliers. So let's add a Nordic joist. So that's what I've got here. And I can tell this is a standard beam just by going into modify. And here I see this is a Nordic joist, an I60 11 and 7/8. So that's the depth. And something important for Sizer to work, well, to connect with this standard part, you see under comment, it says PRI 60. So when you see this, it means that this uh, iJoist can be uh, calculated in Sizer. So most of the vendors, they have like a PRI value available, and we made sure that this can be calculated directly in Sizer. So then the next step is, well, select the part you want to calculate, and then you click on the Sizer interface. Here, because I've already used it a few times, it's already set properly, but if you haven't used it before, you are going to be asked to set the path for Sizer. So you see here on my computer is the path for Sizer is in program files, x86, etc. So you just browse and set the path. So that's under Woodworks. And here I've got like the Canadian and the US version. Here I'm just gonna like select Sizer, like the Canadian version in this case, but the only the database is different for the US and Canada, between US and Canada. But otherwise, like the way it works and like the results you're gonna get are identical. So that's the first step you've got to do to make it work. Then there are a couple things you can do here, like your company info can be written here. I suggest you save values as default. Um, then the project information, you could have the project name, the project number, so you can choose here different attributes. So the first one at the top, these are project data, so architect, customer, designer, deadline, and the name. This is coming, if I close this, this is coming from the project data here. Okay, so then let's go back to our interface. I'm not going to go through all the like besides these settings that you can set up. Oh, one thing I forgot to mention here, you could when you run the calculation, you can also assign a user attribute here on which you will see if that part has been calculated and if it passed or failed the calculation. And underneath here for values, you've got like the different values you will get in the result, like the shear, the bending, deflection, that will be stored in the user attribute number 10. So you can set it up the way you want. Um, then if I jump to the information, here we see that automatically because it's matching the database, it's a floor joist. Then the sizes is fine. We see also there is a cantilever, so that's new in the new plugin from us. It's detecting the spans and if it cantilevers, um, if there is a like no cantilever, if it's a left or right, or if it's cantilevering on both ends. So here automatically that's detected. And then this is an eye joist, and you see here PRI value. So this is what the supplier is supplying. Like these values are matching the design values. Again, I'm not going to talk too much about the rest. Then the span, we see the span. This is like 15 feet span, and then there is a 3 feet overhang or cantilever. You can manually define the span. You can check if there is an issue because Cadwork is detecting the contact with the bearings. So sometimes, well, if you have to check if your model, if there is a collision, then it won't be detected. If it's not touching, then it won't be detected as well. So there are cases where you might have to manually define the span. Then if we go to the loads, here I've already selected or saved some loads. So here floor, you see that there is the dead load, there is a live load. If I click here, you see the different loads that are available in Sizer, and also the type of loads can be selected here. Um, so here I could add some load, I could delete loads, and then I can save them. So for floors, eventually for roofs, you could also add like the snow load. I will check with the rafter here later on. So once you're happy with this, you can jump. You could stay in loads. You see at the very bottom here, you've got different options. So show element, it's gonna focus on the element that you are calculating. But then what I can do, I can run the calculation. And you could run the calculation from any of those tabs. Once the calculation is done, it's going to simply jump into the result. And so here again, I'm not going to explain too much these results. That's what Sizer gives us. What's interesting is the fact that we've got the bearing reactions. So these bearing reactions you could take and move down to the next beam underneath, and we could calculate these timbers or glulam beam underneath based on the bearing reaction here. But this is not transferring the load automatically to the part below, at least not yet. Okay, and what's interesting, you could always open the result and see in Sizer how it looks like. So here I'm just want to show you. We've got our eye joist, so it is definitely a joist. You see all the values are matching, the sizes. Obviously, the loads are matching with what I entered before. And we see there is like a drawing showing like an elevation showing the spans and the bearings. Okay, so now I can close, no need to save, and I could jump to the next part. Let's look at this glue lamp beam. So again, here I've got some bearings. So it's important here. I do have a bearing. I do have a bearing also here, and I have a really small cantilever here. Now you've got to be careful because there are like the material database is so big. We set the material and the properties automatically for the um, I-beams, but it's not done automatically with timbers and glue lamps. So if I jump back into the sizer plugin, we see this is definitely a beam, but then I need to define what it is. So, okay, let's say it's duck fur, then it's a duck, it's a glue lamb EX duck fur, and then I can choose between a 20 FEX or 24. We see there is a cantilever, so whether it's right or left, it's based on the beam orientation. So if it's the beam start is left, the beam end is right. So we see indeed there is a cantilever on the right because that's on the beam end. You see the length arrow or length axis sticking outside of the beam. Then the span, again, it's automatic. I don't need to worry about this. And then for the load, let's load this. But here for this beam, this is way too low. So what I can do, I can change that for the uh, dead load. Let's change that to 400. For the live load, let's say 200, and let's add some snow load here. So I'm just gonna quickly set this, and then let's say this is 600. So that would be based on the bearing reaction of my um, rafters eventually. So once I'm happy with it, I could save this, and I could say, okay, that's the roof, whatever. Like load combination you have. So roof one. Okay, so now you see I've got these load combinations saved. So eventually, well, maybe not so much for roofs, but for definitely for floors that can be pretty handy. Um, then I can run the calculation and let's see what we are getting. Okay, that's fine. Another improvement I forgot to mention, that's under the information tab. What's new um, in the latest plugin is the fact that we can define the fire resistance. So I could say, okay, I want this beam to resist 60 minutes. You could say I've got some fire protection. No, I don't want to hide this beautiful beam. And let's say I've got these faces exposed to the fire. I could say, well, it's all exposed. And then if I run the calculation once more, this is going to be taken into account. So that's a pretty recent improvement we've done in our plugin. Then let's look at the result. So if I open it in Sizer, let's look at the result. So you see here that's automatically filled because it was filled in our plugin, so it matches what we've got here. So the last part I'd like to show you is there is a little bit something special for parts that are at an angle. So if I select the rafter, Okay, that's Douglas fir, timber, grade. And then if I look at the cantilever, well, you might think, well, here there is definitely uh, an overhang, but here, how come it's defining like both? It's just because of the way it's considering the bearing, the support. So the support is actually the center of the support, and so there is between the center, if you project, if you ignore the like um, the slope, uh, the the midpoint of the bearing surface and the tip, there is a distance, so that's considered as a cantilever. A really small one, if I look at the span, we see that this is zero point 0.4 of a foot, so not much. So I could either like just leave it this way, or I could overwrite the span and change to let's say 10 feet. So I could check that and delete this here and change it to 10 feet. And then here I would say this is left. So the bottom of my rafter has an overhang, and then I could go to the loads, and here roof. Well, that's way too much here because it's gonna it won't pass for sure. So let's change that to 100, 120, and maybe snow load 200. Let's see what we get here. There we go. I'm lucky. I see like on the overhang at the end there is no bearing obviously, and then I've got two bearing reactions, one at the ridge, one at the uh, towards the eave, and then I can open it in Sizer and let's see how it looks like. There we go. So pretty straightforward. Um, yeah, I think it gives you a pretty good overview of what's feasible in our new Sizer plugin. I hope you enjoyed it. And yeah, if you have any questions, get in touch with us.